Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
The rocket was invented nearly 1,000 years ago. Since its inception, it has allowed us to go to the moon, travel to other planets, and send our culture beyond our solar system. However, research and innovation is still being done to expand on our current capabilities. UTSA has decided to join this venture by announcing an aerospace certificate in 2019 and increasing efforts to further our understanding of propulsion.
My research program develops advanced diagnostics for very harsh environments like rocket propulsion flows. And in order to develop those diagnostics, I need a way to test them locally in a way that allows me to fix something or iterate on the design very quickly.
A rocket motor test stand is a piece of equipment that measures thrust. This is important for students and researchers alike so they can test their theoretical data to the real-world calculated values.
Having this test stand at UTSA is going to give my laboratory research capabilities that I wouldn't be able to have anywhere else. So I can test diagnostics in rocket flows without having to go to someone else to test their rocket engine, sign a bunch of non-disclosure agreements, work on someone else's schedule. So it's much more convenient for me to iterate on diagnostic design and implementation if I have the device here to test. Additionally, and importantly, having this type of testing capability at UTSA is going to provide students with practical engineering experience, the ability to analyze real data, thrust, flow rate, exhaust composition, that they could not obtain easily otherwise, and compare that with theory. They can really get a step up leaving here that they wouldn't have otherwise.
Our team was tasked to design a test stand that can be the jack of all trades, whether it needs to have liquid, hybrid, or solid fuel rocket propellant, or whether it needs to actuate valves, measure temperature and pressure, or have an additional equipment for laser spectroscopy. Our design meets those expectations by having ample space to attach fixtures and mounting components. Additionally, the test stand is constructed of T-slot rails from a source with a large catalog of different fasteners and construction materials that work interchangeably with the design. This allows for future users to easily modify the design and have many options of mounting hardware that were designed to work with the system.
Traditionally, test stands are large structures built out in the middle of the desert or some isolated location, made of large pieces of steel and concrete, and are not easy to move or replace. Unlike traditional test stands, our test stand is very mobile and lightweight. It's going to be weighing less than 100 pounds and will easily fit in the back of an SUV or truck. Our team has also designed a mobility cart for this project so that the test stand can be easily moved from the laboratory to the parking lot at UTSA.
The main job of the test stand is to securely hold the engine and the associated hardware while simultaneously measuring and recording the thrust from the engine. The rocket engine mounts to the test stand with a sled. The sled allows for easy installation of the rocket engine. The force from the rocket engine is transferred to a thrust plate that has 3 load cells. The load cells measure and record the thrust from the engine while it is firing. By measuring the thrust throughout the burn time of the test, engine operating parameters like specific impulse can be determined. This allows the user to compare their calculated values to their experimental ones and determine the overall efficiency of the engine.
In addition to the force measurement system, the electronics can also collect pressure measurements. All sensors are interpreted by the data acquisition device and recorded by the onboard computer. The system was designed to accommodate 3 force sensors and 5 pressure sensors, and a breakout is found inside the electronics for the user to add any sensors that they would like to use for testing. The second aspect of the electronics incorporated into the test stand is the control system. It is really important to whoever is using the test stand that has precise control over the ignition or any solenoid valves that the engine's fuel configuration might have. To give the user precise control, the test stand has a hardwired controller that operates up to 16 different actuatable devices, such as solenoid valves or electric motors. It also has a safety cutoff switch so that all of the valves can be shut off at once as needed, depending on any emergencies. All of the electronics were designed to be as modular, replaceable, and independent as possible so that the system can be easily adapted or changed in the future. If anything needs to be added later on down the road, it can easily be done with the electronic configuration that we have.